Alright, a little Halloween music, because it is October, my favorite month, approaching Halloween. Basically my favorite holiday. Love this time of year. Let's talk about knoxcraft Turtles 3D. This is the Minecraft lab. So, things we need to know. We're focusing on Java programming using BlueJ to affect the building of stuff in Minecraft. I'll talk about how to connect to the server, show some sample BlueJ code, show you how to use the Java doc to show all the methods that Turtles 3D have available, and finally how to submit your code and run your code with BlueJ, how to make that a little bit easier by hard-coding your player name into the submission.defs file. So the first thing we probably want to see, the knoxcraft turtle site. This link here, we'll go ahead and open it up. It's got documentations, frequently asked questions, some downloads. I've already got it open. I'll go ahead and click on it. So the things you're going to be interested in include the student guide, which has a little bit more general video talking about things for students, and here's the slides for the video. Kind of an example to walk through to kind of show you how to create a turtle and some of the things that you can do with it. And the other thing you're going to want is this API, which should open in a separate window, which you can see over here. API, once again, stands for Application Programmer Interface. This is a list of all of the methods and classes that are available. You can see there's not that many packages and not that many classes. Turtle 3D is the one that we're interested in, and it's got a whole bunch of methods here. Block types, the other thing we'll be interested in. This has got zillions and zillions of different types of blocks for Minecraft. I'll go ahead and show you how to use those. So that's the knoxcraft site. Now to connect to the server, our Minecraft server is running on Leibniz, leibniz.lab.knet.edu. This is behind the campus firewall, so it is only visible on campus. The world, I should just note for people that have played Minecraft before, it's going to be super flat, you can't break blocks, and you can't place blocks except using a Java program that you've uploaded to the server. So if you want to play Minecraft, please go play Minecraft, but if you want to learn to program three-dimensional Java code, then go ahead and use Minecraft just to visualize the awesome buildings that you've built. So let's look at the sample BlueJ code. So I have three sample programs: Cube, which is basically a giant cube of blue wool, the Lithuanian flag, and the waving Lithuanian flag. So the Lithuanian flag is if there were a slight breeze blowing against it. Now this will be available on Google Drive for you to download, all of these codes. Let's just kind of look at this. This is the cube code in BlueJ. And you can kind of see we've got import statements. Okay, we've seen that before. We called it cube. Well, we can name it anything we want. We've got a main method. And in the main method, we're creating stuff. You know, we're creating a cube. We're setting some methods. And we've got some for loops. So, once again, import statements. The important stuff, we've got Turtle 3D. We've also got block type and direction. These are coming out of Canary mod, which is the server-side mod that we're using to build all of this stuff on top of. So you just need to import these three things. If you can't remember exactly how to type them, just look it up. First thing we have to do is actually create our turtle and give it a name. Since this particular turtle draws a cube, I'm going to go ahead and name it Cube. Now the rest of the code actually uses the knoxcraft Turtles 3D API. So the first thing we're doing is we're setting block place to true. Set block place, you can give it either true or false. This is equivalent to basically pen up and pen down using the two-dimensional turtles. Now we're setting the block type to blocktype.bluewool. This is where the API comes in. So if we go to our API, and remember, if you want the API, you can always just go to the student guide and click the API, or you could bookmark it or something like that. It'll also be linked from the lab description. Click down here on block type, so we can see we've got acacia door, acacia fence, we've got, I don't know, cobble, coal, or clay. I don't even know, lime-colored wool, magenta carpet. I mean, we've got all these different block types. And the way you use them, you just type block type dot and then the name as it's written here. These are basically constants. We've used constants without really knowing what they are. Technically, they're a special type of variable called a static variable. This is really the only time we'll use it in 141. We've actually used these before, believe it or not. Color.red, color.blue, color.green. Those are actually static variables as well, but there's many fewer of them than there are Minecraft block types. So that's what's going on there. Before we get to the other two, let's go ahead and show you how this works. So the first thing I'm going to do, I need to log into the server. Now, I should mention, you don't want to do single player because then you can't get to our server. To get to our server on Leibniz, you need to do multiplayer. Now, you'll just create a new server. You can name it anything you want, and the address again is leibniz.lab.knet.edu. I should mention Leibniz is a mathematician. All the servers, the Linux servers in the Math CS department are named after mathematicians, so Leibniz, Euclid, Huygens, Lagrange, which I always call Lagrange, like it's the ZZ Top song, the one that goes it's a great guitar riff. Anyway, so you'll put this information in, then you'll be able to connect. Now, I'm not on campus. Remember, it's behind the campus firewall, so I can't see it. I've actually got my own copy of the server running on my laptop right now, which is why my battery's draining so quickly. So I'm going to go ahead and do that and click join. And so, haha! There we go. So you can see I'm on the server. It's super flat, and there's no monsters. I can't break blocks. I can punch them, but they don't break. And it's actually in creative mode, so I can fly, which is kind of nice. Now, I also can't place blocks. I can even try to, look at that. The blocks can't be placed. I can drop them, which is interesting, and then pick them up again, but I can't actually do anything with them. So I'm just going to leave that there and run over here. So I want to go ahead and draw, like suppose, for example, totally hypothetically, I want a giant cube of blue wool. If only I had a program for that. Well, going over here to BlueJ, luckily I do. This is the sample starter code that will be available through Google Drive. We've got cube, Lithuanian flag, and the waving Lithuanian flag. Let's go in here to cube. So you can see this is exactly that code we were looking at in the slides. We're creating, let me just sort of walk through this. So the first thing we do, we're going to create a turtle called cube. Now, one thing I should note, this looks kind of like a constructor, but it's not. It's technically what's called a static factory method. There's some reasons behind the scenes why we had to do it this way. This ends up calling the constructor for us. It's just sort of some technical details as to why we're doing it this way. Static factories are a common pattern you'll see people use when you get into more advanced software engineering. You don't really see it in 141 that much. I think this is probably the only time that we'll use this in 141. And you don't even need to really use this. You just need to know that inside Turtle 3D, there's a special method called create turtle. I give it the name of the turtle, and it spits out a turtle. It's basically just a giant function call. We're setting block place to true. That is equivalent to setting the pen down. Now we're taking our turtle, we're setting the block type to blue wool, and then now here's my actual Java code. So I'm setting size to 8. I want to make it an 8x8 cube. And now I've got my for loop, j starting at 0, j less than size, j++, and then I starting at 0, I less than size, I++. I'm turning block place on again. I'll show you why in a second. I'm going forward size. So the way this works, there's not like literally a turtle. You don't see a turtle. It's just conceptual. Wherever you're standing, it will basically create an invisible turtle, and that turtle will drive around faster than the eye can see, laying blocks behind it. So when block place is on and you move the turtle, whatever the block type is set to, it's basically going to drop those blocks out behind it, almost like the 2D turtle did when you told it to go forward and go backwards and turn right, and it would leave lines behind it depending on what the pen color was. This is going to do the same thing. So we've got set block place to true, we're going forward size, then we're turning block place to false, going backward size, and going to the right 1. And right doesn't turn right, it actually slides to the right. And so that's what we're doing. And so you can see we're going forward size. So we're going forward 8. So think of it, we're going forward 8, back 8, right 1. Forward 8, back 8, right 1. We're doing that 8 times. And then after one of these loops, in other words, so after we've done kind of like one layer, we're setting block place to false. We're going back left the distance that we had gone right, because here we went right 1 at a time, size times. Here we're going left by size, but we've got block place set to false, so we're not changing any of the blocks. Then we're going up 1. Then this loop is over. We come back up here. J gets increased by 1. We do this stuff again, right? So that's why we're turning block place on when we want to be drawing. We're turning it off when we don't want to be drawing. So that's basically what's going on. Let's see how this would work. So the first thing we need to do, we're logged in. Oh my god, the battery's draining fast. We're logged into Minecraft. Here we are. It's perpetually noon. It's super flat. That little block is still there, but I want to draw my cube. So what I'm going to do is go back to BlueJ, and I'm going to check my submission.defs file, which I think is set correctly. Basically, here's what I would do to check on this. So here it is, labs, knoxcraft. This is in my CS141 folder. I've got this file here called submission.defs. I'm going to open this, make sure it looks okay. Let's see. Yeah, so this is just some weird format that BlueJ uses. It says include star.java, so all the Java files. These just are commented out, and so it's saying, well, I want this to go to Leibniz Lab, knet.edu, 8888, upload, blah, 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 and then this thing here, what is your Minecraft username? Now, I'm going to make a quick change here. I'm going to have to change this over to localhost. The reason being, I don't have access to Leibniz right now because I'm at home. So now, whoops, that's not right. I wanted this, there we go, this BlueJ. When you want to actually submit everything, you go up here to Tools, Submit. That little file we looked at should be set to submit. Yeah, it loaded that file we just edited. knoxcraft, good, good, good. Let's hit submit. It's going to ask for my Minecraft username. I am, of course, going to enter SpackDog. Yeah, and you can see it gives me back some diagnostics. It uploaded all 3 of these programs. So I was able to compile and upload all of them. So that means Cube is now uploaded. It actually uploaded all 3 of them. So if I go back here, if I want to look at them, I hit slash, which is right, sort of right just to the left of the shift key, and I can say ls to list all my programs. And, you know, interestingly, I have a ton of programs, but the one I want is Cube. To invoke it, I hit slash to bring up my little menu. I type invoke, and then the name of the program, Cube. Now, how do I know, before I show you this, how do I know it's named Cube? Well, if you think back to here, it's named Cube because I named it Cube. So let's try that. Bam! Oh my god, that's fantastic. An 8 by 8 by 8 cube. And you can see that basically happened instantaneously. All that code had things go forward by 8, and then sort of pen up and back by 8, and then right 1. And then the loop again, you know, where you put the pen down and it does it again. Cool. Now, maybe I don't want a giant 8 by 8 by 8 cube, or maybe my code was wrong and I didn't really like what I drew. If I hit my slash to bring this up again and type undo, bam, it'll get rid of the thing I just drew. And it actually, believe it or not, goes and sort of like overwrites the dirt here. Cool. So that is a little bit about what we're doing, the turtle, how to submit, so on and so forth. Let's look at the other 2 things here, the Lithuanian flag and the waving Lithuanian flag. So we're going to start with the Lithuanian flag. So a couple things that I'm doing here, creating my turtle called Lithuanian flag, turning block placement to true. I've got a width of 10 is actually not going to work very well. I think it should be, I don't know, maybe 15 and 30 here, because I think we want multiples of 3. There we go. So I'm setting the block type to yellow wool. I'm using yellow, green, and red wool. And I'm calling this stripe function. I'm passing it to turtle and I'm saying width and length. What is stripe? Well, that's just a function I wrote. You give it a turtle and a width and a length. And, oh, this is weird. Huh. Well, I'm going to probably change this. This is weird. I'm dividing by 3 in here, but really what I should do is not do that. I should leave this not dividing by 3, and then I should divide by 3 here. That way stripe works in general. No. Well, talk about a little bug. Well, it's not really a bug. It was just poor design on my part. So what this does, it's given a width and a length. Well, width times, it's going to turn block placement on and go forward and backward length, and then turn block placement off and go right 1. So it's going to give you a stripe of this length that's that many units wide. Now what we're doing here is we're basically doing 3 of those, but each one only a third of the width with the given length. Yellow, then green, then red. That's going to get me the Lithuanian flag, and you can see since I'm dividing by 5 here, sorry, I've got 15, so I'm dividing by 3. Each of these is going to be 5. So I don't need to upload this again, because actually whenever you submit, it uploads everything. And so if you remember last time, if you sort of look at the log here, we uploaded all 3 of them, and 3 files got processed correctly. So let's try Lithuanian flag. So here we go. I'm going to invoke Lithuanian flag. Bam! I'm going to use my tap spacebar twice to fly. Look at that. That actually looks lovely. It's basically the Lithuanian flag. And so if you think about that code, what I went ahead and... This is weird. 1, 2, 3. 1, 2, 3. 1, 2, 3. Is that right? This is 9? And then how big is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's something. Oh! God, I'm such an idiot. You remember when oh, God, here's what's happening. So I went and changed the code in here and recompiled it, but I didn't upload it again, so it was still set to do 10 and 20. Well, that's actually something that can happen. So it's something to keep in mind, because it uploads all the code every time. So let's try this. Submit. We'll go ahead and submit. I got to type in my username again. And look at that. 3 files. Okay, good. Let's come back over here. I'll undo this flag. So that's gone. And now I'll come back over to this big mass of dirt, and I'll do invoke Lithuanian flag. Oh, much better. Oh, that looks a lot better. Good, good, good. Yeah, now, and you can see 1, 2, 3, 4, 5. Yeah, 5 times 3 is 15. Oh, that's much better. Beautiful. So I'm sort of doing this. It's basically 2 dimensions. I know that each individual block has depth, but it's still basically 2-dimensional. So that's the Lithuanian flag. God, that looks nice. I really like that. Cool. So let's look at the waving Lithuanian flag. Oh man. Oh man. This is fantastic. Oh my gosh, this is going to be amazing. Okay. Well, okay. Let's do this. First I'll show you what it does, and then I'll show you how it does it. So the name of this is waving flag. God, this is so fun. You know, when I was a kid, we never had anything like this. Let me see. Where am I going to put this? I guess I'll put it over here. I called it invoke waving flag. Oh, look at that. Oh, yep, perfect. Okay, let's just fly. Look at that. See, it's a Lithuanian flag, but it's like it's kind of rippling. I mean, it's rippling in like a perfectly even pattern, because that's easier to code. But like, look at that. It's like there's a breeze and it's snapping in the wind, showing the pride of Lithuania. Dun da da da! Awesome. Let's think about how it's doing that. First of all, I think I can kind of go above it to sort of get an idea. yes, you can sort of see what's happening. We're doing almost like a whole column all the way up, and then all the way back down, and then we're going diagonally up one, and then again, and then diagonally down, and then sort of up and up and down and down and up and up and down, and so on. So we're doing this a bunch of times. So here we're taking advantage of the diagonals. So we're not just using whoa, whoops, let's try that again. We're not just using forward and backward. We're also using up and down and turning. And when we turn, we're actually turning sort of 45 degrees and going forward again, which actually gets us these lovely looking diagonals. So let's see how this is doing that. So we're creating our turtle, turning block placement on. We want it to be 30 by 15. Now we've got our code here. For the given width, turn the block placement on, set the block to yellow wool, and then I want to go up the height over 3, and then red wool height over 3 and green wool height over 3. So you can sort of see what that's doing. That's sort of, that's this part. It's going up. Then I get to the top, I turn block placement off. I go back down the height, so I had gone up a third at a time. Now I jump all the way back down. Now I'm saying, well, if I%4 is 0 or 1, in other words, if I is evenly divisible by 4, or if it's 1 above being divisible by 4. So in other words, if it's if I is 4, this is true because 4 mod 4 is 0. And if it's 5, it's true because it would sort of be 1. So I'm basically figuring out, do I want to go top right or bottom right? Because if you think about this pattern, watch this, look what's happening. If you think of this, this would be I equals 0, this would be I equal 1, this would be I equal 2, I equal 3, I equal 4. So for 0, we go top right. For 1, we go top right. For 2, we go bottom right. For 3, we go bottom right. Now we're back up to 4, which is equivalently 0. Top right, bottom right, bottom right, top right, bottom right, bottom right. What do I mean by top right? Well, what that function does is it just says, okay, take wherever the turtle is, turn it 45 degrees right, go forward, 45 degrees back left, and then do whatever it is that you're going to do. So that's what we're saying. If I mod 4 is 0 or 1, those are both top right, otherwise it's bottom right. What's a top right and bottom right look like? Well, that's just this. It's a function, it takes our turtle, and we're going to move the turtle by 45 degrees. What is move, you might ask? Well, that's just this function up here. Given a turtle in a number of degrees, we turn block placement off, we turn right by that given number of degrees, we go forward 1 block, we turn left by that number of degrees. So basically this gets the turtle to move 1 block to the right, but it turns block placement off before it does it. 1 block to the top right. Or really just 1 block in whatever direction we want to turn in. We could use this function in a number of different places. It's sort of annoying you have to keep turning the block placement off and on. That's just how we decided to implement it. So, man, so this is so cool. So that's what that's doing. That's the waving Lithuanian flag and the Lithuanian flag. These are not the most exciting things that you could build. You can actually do a whole lot more. I'm going to go ahead and undo these so that my server's not cluttered. There we go. You can actually do a whole lot more, but that just happens to be what I've got. I'm going to disconnect, I think. There we go. Excellent. Now, what else? There's 1 or 2 other things I wanted to show you. Right, how to submit. So, I opened up this submission.txt file. Now, the way to find this, you go into your knoxcraft lab folder, you find this file called submission.txt, and you open it with a text editor or something like text editor. I'm using Sublime. Now, I get really tired of typing in my username every time, my Minecraft player name, every time I submit. So what I'm going to do is I'm going to comment this out. I'm going to uncomment this. So I'm set to localhost still. And I just went ahead and hard-coded my name. And you can kind of see it's got these little brackets and it's saying field, what is your Minecraft username. This basically tells BlueJ to pop up a window. You don't need to know any of this. Like this syntax is only used for submitting in BlueJ, which we only care about for this one project. So you don't really need to worry about it. But you might get tired of typing this, so just go in there and change it to your username. So if we sort of look over here now, from BlueJ, when I go up here to the submitter, now if I just click submit, it's going to still ask for the username. The reason for that is it's sort of been loaded. I need to close it and restart it. Now if I submit, it doesn't ask for my username. It just goes ahead and submits with that. So like once you close the submitter, every time you reopen it, it rereads this file. So if you make changes to this file, you have to make sure you close the submitter and do tool submit to get it to reopen and sort of reread all those files. This video I think is going a little long and my battery's starting to die, so I should probably stop. I think that's actually everything. Yeah, these are the changes to make. Yeah, blank slide, that's it. Good. Well, things you can build with Minecraft, I don't know. Build a house, build a skyscraper, build a giant pool of water, build, I don't even know. I mean, that's the thing. You get to be creative and decide what to build. One thing I would recommend, spend some time plotting out what you're going to need to do, writing and testing any functions you might need, like that move function, top left, top right, stripe, things like that, because it's going to be really painful if you just kind of like write everything just sort of using the turtle. The turtle's powerful, but functions are more powerful. I guess that's all we've got. Let's close with some more Halloween music. Apparently I'm a huge fan of this genre of music.